And whenever you're ready, by discuss.
Well, Tom, one of the things I always do is try to get my interviewees to give me a little bit of the history of how they got into control, where they went to school, and because I'm interested in the origins of these people. Most of the people I've interviewed had to deal in one way or another with the Depression, the Great Depression, and there's some very interesting stories that come out of this era. Yours are equally interesting, so I'd appreciate it if you just tell us a little bit about how you got started and how you got into Cornell and how things went from there.
Well, shall I start at the very beginning with my birth?
Sure.
Okay.
All the way back to Virginia.
I was born in Charlottesville, Virginia in 1911. And my mother was living there at that time, and my father was working in Charlottesville. They met, got acquainted, and married. So I was born July 4th, 1911, about 18 months after the marriage, I guess. At the age of 4, my father's family had really living in Ithaca, New York, so he decided to return there. So our family of myself, my brother Charles, who was 18 months younger than I, my mother and my father went to Ithaca, and that's where I grew up. I went through the parochial school there in 7 years in Ithaca, New York, because from an Irish family, all 4 of my grandparents came from Ireland in the 1880s. Graduated there, went to Ithaca High School, the usual 4 years, and then started at Cornell University in electrical engineering. I always wanted to take up electrical engineering because in the physics course that I took in high school, I was particularly interested in the electrical aspects of it and the little few laboratory experiments we had and the explanations in class. So I started in electrical engineering. So I had a career of 4 years in electrical engineering. And when I graduated, we had about 46 students in class, and I ranked number 12 in grade point average.
Yeah. What year did you get out of Cornell?
1932.
Right at the heart of the Depression.
Right, at the bottom of the Depression. So there was very little employment right directly out of the university at that time through placement service or something of that nature. So I failed to get a job, and I decided then to return to Cornell in the following year and to work for a master's degree in mathematics. And the simple explanation of why mathematics was this. I wanted to really study electromagnetic theory in detail and felt I therefore needed more mathematics than I had gotten as an undergraduate. So I entered the graduate school, and at that time you had to take a minor. And I decided, therefore, since I wanted to be a college professor, I always had that in mind from the very beginning as an undergraduate, or maybe midway through my undergraduate years, that I would take a minor in education. So I took the courses for 1 year in mathematics that were required, but also I took the 18 credits of education that was required for a state high school teacher's license. And you had to have 24 credits altogether. But the thesis work filled in the other 6 credits, so I had 24 credits. But for various reasons I won't go into in detail, it turned out that I didn't have a thesis done at the end of the year. So I didn't get the degree at that time, which would have been June of 1933. However, I finished all the rest of the work except the thesis on a very difficult problem, which perhaps will be mentioned later.
Yeah, we'll come back to that because it's an interesting story in itself.
So that summer I worked, and then through one circumstance or another, I had the opportunity to go to Auburn, New York, where Syracuse University was operating what was termed the Auburn Intercollegiate Center, as I recall it, this 60 years later. And what it meant was this. Syracuse University accredited courses there that were offered, and they used rooms in a high school that were available. So students who were, for one reason or another, unable to go elsewhere in the time of severe depression there could still do freshman work. And so I taught mathematics for the one academic year there. Calculus, trigonometry, advanced algebra, and maybe solid geometry if that was offered. And at the end of the academic year, when I returned back to Ithaca to go to summer school at Cornell University for the summer, I received later in the summer information that the appointment wouldn't be renewed, and for a rather simple reason. It was funded through federal, I suppose, if not state funds, as a sort of a welfare operation, actually, that they had in those days, like the WPA. And they were going to have somebody from the local vicinity there. Ithaca and Auburn are 40 miles apart. So I immediately started hunting for another job, and I hitchhiked around for a month or so, visiting cities in the immediate vicinity of Ithaca, New York, like Groton. I went up to Groton, where Smith Corona, or whatever the name of that outfit was then, had their big typewriter works. Nothing there. But eventually I went to Binghamton, New York, and after walking around looking at various factories, and I came to AgFansco Corporation, which is a chemical engineering outfit. A German firm of AGFA had come into the United States, bought the old AGFA plant, modernized it through new construction and so on in 1928, 29, and hadn't done anything subsequently there. So I thought at first it was a chemical engineering plant. I was an electrical engineer, why go in there? But after a couple blocks, I turned back, went to the employment office, and they were looking for somebody to do drafting. So I interviewed the assistant chief engineer, a German by the name of Jeep, a former World War veteran, had a couple scars on his face that evidences experiences. And I was hired to report for work the following Monday as a draftsman. And what I did subsequently was this. A few months earlier, they had hired a Swiss-educated engineer who had come to the United States and was out of work for a couple of years, living on his brother's dairy farm down in the Poughkeepsie Valley. He answered an ad in the New York Times looking for that the company had placed, and they wanted a designer because they had to do some design for new equipment to be installed. He had come there, done some designs, and now they needed somebody to do the shop drawings. So that was my job. So working with Cotman, I did the shop drawings. Then the next thing was to carry the work through the machine shop. They had a big machine shop there to have it manufactured and so on. And then to follow through the installation, surveying the workmen as they worked in here in the plant. So I did that for essentially a year, from October to October or something of that nature.
What'd they pay you?
Well, that's an interesting point. What I got when I first taught at Auburn Intercollegiate Center, and I taught 5 mornings a week for 4 hours, the pay was $15, which wasn't bad for those days.
A week?
Yeah, for 5 days.
Yeah.
Now, when I started at AGFA, the pay was $20 an hour.
$20 a week?
Yeah, I misspoke, yeah. $20 a week, 5 days a week, and also Saturday mornings. So you work 5.5 days. So I held that job. But I'd always wanted to get in to be a college professor business, you see. So through the school placement at Cornell, placement office, I got a letter saying there might be an opportunity at a small engineering college which offered 3 years. Those who wanted to go on for a 4th year and get an accredited degree would usually go up to Penn State and finish up there. That was an arrangement. So I obtained that job. So I left.
That's why I'm missing. Right?
Yeah. I left AgFansco plant, went down to Wyomissing, which is a suburb of, essentially speaking, adjacent immediately to the city of Reading, Pennsylvania. And this was a small engineering school of a couple hundred students at the most, with a faculty of 8 teaching different areas. So what I did there was to teach, in the first year, electrical engineering courses, basic circuits, basic fields, rotating machinery, AC and DC machinery. They had 3 years over there. In the second year, the man who was teaching calculus left, so I took on the teaching of calculus. I also taught statics and dynamics using the well-known book of that time by Poorman. I also taught a course the equivalent of relative to thermodynamics, including thermodynamics, called heat engines, using the book by Burley, or Hurley, as I remembered at this date, was the author of it. So, but at the end of 2 years, which was a very satisfactory teaching experience, all these areas in here, I still wanted to be a college professor. The thing to do is to get a PhD degree for a subsequent career. So in my first year there, I had sent out 60 letters to various colleges of engineering that offered the PhD degree, and I received no offers. The second year, I did the same thing. And in the spring, when I came home one noon, they had 2 mail deliveries in those days to check on the evening mail during lunch hour. There was a letter from Purdue University offering me an instructorship, as they called it in those days, to work for a PhD degree. And the salary offered was $1,800 a year. So I immediately picked up the phone, called the department, contacted the chairman, Professor C. Francis Harding, who was chairman at that time, accepted the offer. In the afternoon mail, I got an offer from the University of Arkansas, which I wrote a letter declining. I already had an opportunity. And subsequently, it appeared, the floodgates had opened up. Students were flocking back to college. The universities really hadn't been hiring much in the way of new faculty during the Depression years. There were low ebb, people had retired, and they needed help. So I received 17 offers altogether by the middle of October from other schools that were coming in.
I had a question, though, about, you did get your master's from Cornell eventually, didn't you?
Yeah, I did. You want me to go into that now?
Yeah, because I want to talk about this math professor who had an impact both on your undergraduate and your master's program.
Now, while I was at Wyomissing, at the end of the first year, summertime, I went back to Cornell to pursue graduate classes and to work on this thesis. However, the man whom I'd originally wanted to work with, Professor Wally Abraham Hurwitz, isn't that a great name? Yeah. I had been, the year I was there, on sabbatical back in Germany, where he'd gotten his degree earlier before World War I, at Göttingen, as I pronounce it. So I was now able to shift from the man I was working with originally to Professor Hurwitz, who agreed to take me on and work on a project we were both interested in. So that summer I worked on that. The second summer I returned to graduate school again and did that. And the net result was that in 1937, in June, I did receive a master's degree in mathematics from Cornell University. Just in time to be able to then report to Purdue with a degree in my hand, you see.
Maybe just a word more about Hurwitz. Your interest in him goes back to when you were an undergraduate, right?
Well, yes, I had an unfortunate experience in, in taking calculus in the very first term as a freshman, and unfortunately the teacher, it also was a professor, assistant professor who had just gotten his degree earlier, and this is his, I think, his first teaching experience. And the net result was in the middle of the semester, half the class were sunk, including myself. So I simply dropped out of the class, too late to withdraw formally, concentrated my efforts on the rest of the semester, and pulled it out. Because with this calculus of 5 credits, as it was then, and I was having a little difficulty in physics, it would have been 10 credits maybe failing. I certainly would have been dropped from the freshman year at that point. See, might have gotten readmitted, but anyway, I would have been dropped for sure. But I let the 5 credits in calculus go. I pulled out the physics with a B, and all the rest of the courses were A, so I survived. It was an interesting experience for your freshman year, you know, the transition from high school, where I was essentially a straight A student all the way through, to getting into a freshman where nobody cares really except what you do yourself. You get sunk. That counts for a lot of failures of students in their freshman year, that kind of experience.
It was fortunate in a way, though, because you meet Hurwitz on the next pass.
Yeah, the next semester I took the calculus of Professor Hurwitz. He was a very excellent teacher. I got an A in it. So that's the difference in teachers right there, for example.
You know, plus he was instrumental in your master's degree. So.
Well, yeah, subsequently I took another course as an undergraduate. After I finished calculus, the next course in those days was usually differential equations. So I was able to fit that in as an elective in my undergraduate work, and probably in my junior year, I suppose. And subsequently then, I did a thesis with him, and we finished up, yeah.
Now it's on to West Lafayette, Indiana, to Purdue University.
Well, I reported to West Lafayette, Indiana, and I had no idea really of what the university situations were between the Allegheny Mountains and the Sierra Madre, as far as I'm concerned, or even further in the Pacific Ocean. So it was an interesting experience, because State University in the Middle West and here are quite a bit different from the, at least the one Ivy League school I attended, Cornell, you know, structure and all that kind of thing. So I arrived on a motorcycle. I didn't really have enough money to buy a car in those days, you see. You were just struggling, making ends meet, for the most part. And on the salary, you got $15 a week, $20 a week, you know, cover your living expenses. But when I was at Wyomissing Polytech, I did buy a motorcycle with a sidecar.
With a sidecar?
And I had, yeah, with a sidecar. And I had that for the second year I was at Wyomissing, see? So I was then, had left, gone to Ithaca for the summer to graduate work, and I left from Ithaca to go to Lafayette. And I could pack all my belongings in the sidecar. That's why I had a sidecar, okay? Take several vans now to move myself, practically. So I arrived driving my sidecar. Went immediately as I drive there. I checked into the equivalent, not a couple blocks away, of a tourist house, okay, for the day or night, and reported to the office. And I received a warm reception, I remember, in the office there, and so that was the start of my career there. I must hasten to add, maybe get the sidecar out of the way, that after a year, I was informed, you know, in a friendly way, well, instructor at the university, member of the faculty in a sense, wasn't very dignified driving a motorcycle with a sidecar. So at the end of the first year, you see, I went back to Ithaca again for this reason. I went back there because surroundings in Ithaca are very pleasant, so I would take classes in the morning in mathematics and in physics, conjunction of the two, and then transfer the credits back to Lafayette. And in the afternoon in here, well, one played tennis on the faculty courts there behind Rockefeller Hall, the physics building, or you could join the club for, I think it was something like $7 for the summer. 3 nice courts. Or I could go swimming. And a number of favorite swimming holes around Ithaca, New York. There's an artificial lake on the Cornell campus, dammed, which is about half a mile long and so on, and had a nice swimming hole in it, BB Lake. Or you could go down to Cuga Lake, and I had friends there that had cottages along the lake, and in particular one close friend who was working for a PhD in chemistry. His family had a rather nice house with a boathouse where his father had a fairly large boat, and there's a room above it, sort of like a garage on the second level, kind of, because it was a boathouse level. And to swim off of their pier and so on, see. So that was the summer for the weeks. Then, of course, visit with my family, yeah.
So you're trying to tell me that it was better in upstate New York than Lafayette, Indiana in the summers?
Well, you have to remember that the middle New York State is, the so-called finger regions, is a very scenic region with rolling hills and lots of lakes and all that scattered around. And Lafayette is a rather flat area in West Lafayette where the university is located. And the city itself is an industrial area and doesn't have, at that time at least, too much in the way of what you might call cultural activity. And Ithaca had, and particularly in the summer schools, you see, with school teachers flocking in to take courses and so on to maintain their teaching license, a certain number of hours are required, so-called continuing education. It was a very nice place. where I did spend one summer, finally, at the whole summer at Purdue, my last summer there, between my third and fourth years. Yeah. And I must say, it was a little bit warmer there than it was in Ithaca during the summer.
Of the faculty at Purdue while you were there, who really impressed you the most?
Well, of course, they had about 10 professors at that time. I think that was about the number of the faculty. And the man who was the chairman of the department, C. Francis Hart, they call it the school, and I think maybe they still use that term of electrical engineering rather than the department of electrical engineering. Okay. Was it had come from the East, and if I remember correctly, he was a Dartmouth graduate. And had come out there and had been there for a number of years. It seems to stick in my mind that he come there in 1910. I'd have to check that figure, but that's about right. He was a man probably at that time in his 60s, I'd say. Tall, very dignified man, and had a rather austere, whichever way you pronounce it, countenance. He was the chairman of the department. Now, in that office, where in sort of the middle of the big room the department secretary sat and functioned, then they had two smaller offices on each side. And therefore, one of the offices immediately adjacent to Professor Harding was occupied by Professor Ewing. And if I remember his initials correctly, it was D.D. Ewing. And he was a man at that time, I think, in his 50s. And if I recall correctly, Ewing is a Scots name, or Scots, take your choice. And he had a consulting arrangement, maybe he was even a shareholder to some degree, I don't know, in the Duncan Meter Company, which was a company in Lafayette that manufactured electrical meters of various kinds, including watt meters. And he also had a farm adjacent to the campus, not too far away from it, but of considerable size. I once visited on his farm, but I don't remember the details about him any further. And I did my PhD thesis with him. And the problem that I worked on for a PhD thesis is like this, you see. In Maxwell's book, A Treatise on Electricity and Magnetism, which Maxwell published in 2 volumes in 1873, it subsequently went through 3 editions. In the second edition, Maxwell died in 1879, you recall, as a fairly young man. The second edition was then edited, you would say, by a well-known astronomer, physicist astronomer at the time. And if I recall correctly, it was Dyson, D-Y-S-O-N. And he didn't really change anything in the text except to put several footnotes in. And one footnote pointed out that a problem was being considered there in Maxwell of a pair of conducting wires. Maxwell had assumed that the permeability was the same as the permeability of the air, and they would otherwise depend upon which units you're in, one, right? But in a footnote, Dyson pointed out that if you'd had iron wires instead of wires of permeability 1, then you'd have a different solution than the one given in the textbook. So this struck me when I read that as an interesting PhD thesis project. Work out the mathematical theory, assuming the permeability is other than 1, but a constant anyway, okay? And the surrounding atmosphere would be permeability of 1. So that's the problem that I tackled for my PhD thesis. Well, I suggested this as a problem to Professor Ewing, and he agreed. Go ahead and work on it. So I did. I spent about a year and a half, I suppose, working out that problem, getting the thesis typed up. He read it, approved it, and that was it. Subsequently, I hasten to add that 2 of the chapters of my thesis, because I also assumed the case that you could have I'll put it this way, eccentric cross-section in one fashion or another, as well as just circular cross-section, okay? And I worked that out, various shapes there. Were published in as papers in the Journal of Applied Physics, if I remember correctly.
How long were you at Purdue altogether?
So I was there 4 years.
So you leave Purdue in 1941.
That's right. After the end of my 4 years at Purdue, I then received an appointment to go to Tulane University as assistant professor. Yeah.
And you went to Tulane. You were there a short time, I guess, a couple of years, maybe a year.
Well, no, I went down there in 1941, but the summer between leaving Purdue and going to Tulane, I spent working in New York City for Basco Services Corporation. I forget exactly how I made the contact, but anyway, I applied for the job for the summer, was accepted, and interestingly enough, the chief engineer there that I had an interview with and employed me was also named Harding. I don't know if there's ever any connection between the two of them, because also there was President Harding and so on, you know. So I worked there that summer. The Basco Services Corporation really took in jobs from various public utilities and did the work. They were design jobs for the most part, like designing relaying for new transmission lines or looking into problems connected with central station operation and all kinds of things that went with public utilities. As I recall earlier, Basco Services had been sort of the service organization doing that kind of work for the so-called City Service Corporation, of a great conglomeration of utilities that sort of went bankruptcy during the Depression, and it was in, or later anyway, still in existence there, functioning on an individual basis, accepting work. So I did a couple jobs for them that they assigned to me, and at the end of the summer I then left and went to Tulane. Yeah.
Let me ask you a question here, going back to Purdue a little bit. There were, you say, about 10 professors.
Roughly, there were 10 in the faculty. Yeah.
What were the primary areas that they were concentrating on?
Well, let me think for a second. Now I can remember most of the professors. There was Harding. His specialty was high voltage. At that time, one of the things that some universities had was a high voltage laboratory, and we had a 1,000,000-volt high voltage laboratory there. And the idea that was his particular interest, and it was the laboratory was sort of the laboratory work was carried out under the supervision of Professor Marshall. He might have been an associate professor at that time, Marshall. Marshall also taught electrical measurements, and actually subsequently was the author of 2 volumes on electrical measurements, because the first semester was DC measurements and the second semester was AC measurements. So he wrote these 2 volumes in a sort of a spiral-bound book, you know, soft cover kind of arrangement, which actually I subsequently used for 1 year when I ended up at here. Because they were teaching essentially the same course. They used to be a standard course, DC and AC measurements in all engineering departments. Those sort of got pushed out after World War I. Eventually, a lot of schools dropped it. Yeah. Electronics came to the fore rather than the old measurements, you know, of AC and DC instruments. See, there's a difference for them, yeah. And so Marshall was there. And I took a 3-credit course in that high voltage laboratory, as a matter of fact, as part of my undergraduate instruction. One of the things is to measure the breakdown voltage between 2 spherical balls mounted on insulators, and you put a high voltage between them, and you move the balls to see how the breakdown voltage varies with the distance between the balls. You see, it's sort of a standard kind of operation. Another thing was to charge a circuit with a high voltage bank of capacitors that were charged in parallel, let's say 50,000 volts each, and then by a series of spark gaps that broke down simultaneously, they'd all be shifted into series. So that's where you got the high voltage from these capacitor banks, see? And that had to discharge through something. And what it discharged through would be a hose filled with water with some salt in it so you could vary the resistivity of it, you see. And then there was a certain amount of inductance associated by plugging in the equivalent of coils into the circuit. So you could study the transient phenomena on an oscilloscope screen. That's what it came down to. And see how the shape of the transient and varied with the parameters of the system. That kind of thing they did, yeah. Then another one is that Purdue had at that time, it may have been subdivided since, but the fact that they had a laboratory and they had an electrically driven trolley car, which was kept on tracks outside because there used to be interurban lines. You know, you could get on in Boston and ride interurbans by transfer all the way across to Los Angeles. These short lines, as they were called, electrical, running through the countryside. So by this time of the 30s, those interurban lines had more or less disappeared. But at one time, there had been a considerable amount of that network in Indiana. And as a matter of fact, I now recall that Professor Ewing is the author of a book published about 1917 on electric lines. Okay, I'd forgotten that. But this is now reminded, because one of the cars was still there. They used to bring it into the lab, so you know you could open these great big doors and they'd move in this trolley, as I remember it, and you could run experiments on it. Okay? I never did, but it was still, the thing was there at that time. It disappeared shortly after I came there, as I remember. However, see, the big laboratory work that day was electric machines in the laboratory. And that laboratory, sticks in my mind sort of as the length of a basketball court. And it was 2 stories high, because there's a balcony that ran all the way around it, or at least 3 sides of it on the second floor, second level. So it had a high roof, okay? And of course it had the usual thing with a big overhead crane structure that you could move heavy equipment back and forth and so on. You may remember that. You were there.
It was still there when
yeah,
I was
sure,
there.
Okay. And but the interesting and fascinating thing about that laboratory is that they had collections of a large number of electric machinery, motors and generators of different types as they'd been developed through the years. And there's a 2-volume book written by Professor Kerr Padoff, who was a longtime professor of electrical engineering at Cornell University. And as a matter of fact, he lectured to the seniors in a certain course that everybody had to take. He also gave a seminar course, the equivalent of it, on Heaviside's operational calculus. And I took that course, and that was my introduction to Heaviside operational calculus. I also got acquainted with Kerr Padoff in a different way. He was a member of the board of trustees of a foreign student house where I had an association for some years. And so I got to know him somewhat better than if he had been just a professor, okay, and I was sitting in his class. Furthermore, in his old age, he suffered from detached retinas. And after he retired from Cornell, he took up residence, as I recall, in New York City, and had some difficulty with the surgery attendant detached retinas and so on. So I once suggested, maybe perhaps I could arrange an introduction to you to Professor, or Doctor, not Professor Carrazzo, my friend who was in the bacteriological laboratory at Columbia University and here, and who might be able to help him and steer him relative to the ophthalmology department there. So there was an introduction made, and he did receive some treatment, but the outcome is such that he died blind, actually. But he had written a 2-volume book, which went through at least 4 editions, and published by, if I recall correctly, Wiley. And this had a section to begin with on circuits. Then it had a section, most of the book dealt with laboratory, it was laboratory experiment instruction kind of thing, you know, all experiments aren't lined and so on. You could follow and do a laboratory experiment. But on machines, motors and generators and so on. So when I was at Purdue then, I had my copies of his book, which obviously I must have bought as a textbook when I was at Ithaca. And I used to work in the evenings just running experiments because they're so fascinating to do on all kinds of electric machines there. For example, there was they must have junked it later, but there was an AC to DC, DC to AC converter, so you could put in AC, take out DC, or vice versa, you know, which were used in the old days when you had mixed wiring, AC coming in, but you still had old DC in the building, and you stuck a converter in between them. Or you could have all kinds of fancy rotating electric machines where you could vary the speed by turning a crank in here, and that shifted the armature axle, if you want to call it an axle or a shaft, I guess is the correct word to use, and that varied the speed. All those kinds of machines were fascinating. So I'd just go in there and run experiments on all those different machines to get acquainted with them, their characteristics and so on. What I did as an instructor there for the first 3 years, practically, was that I had 4 sections of a course that non-electrical engineers had to take. And these sections were this. They had about a maximum of 28 students in them, but they'd run around 25, 26, 24, something like that. And the reason there was a maximum of 28 is that the same students then divided into groups of 4 each and had a laboratory experiment running through 3 weeks. So each week there was a laboratory experiment. So I taught the classes for 3 hours, Monday, Wednesday, Friday probably, okay, 1 hour. And then I had this, I said 3 hour, but I think it was a 2 hour laboratory. Well, maybe it was 3 hours, but altogether added up to 5 hours. It's a good credit, I guess. And so I had these 4 laboratories a week, plus the 4 classrooms a week, plus the fact I demanded, and I started even at that time, as I told you yesterday, that students had to turn in a set of problems every day, which I graded and turned back the next period. So I was grading, therefore, 300 sets of problems a week, because I had roughly rounded off 25 4 times, 100 students, 3 times a week, a set of problems. And also, I had to grade 100 rather elaborately written laboratory experiments, because every student had to write up a sort of formal laboratory report in those days, and it ran for 14 weeks, see? And I never had a grader. I always wanted to do all the work myself. So, interesting comparison with what graduate student, a TA would be doing at the present time, or an assistant professor.
Any of us, probably.
Yeah. It was 20 contact hours a week, 300 sets of problems, and 100 sets of laboratory notebooks to grade. But it was interesting. I enjoyed teaching. Well, unfortunately, I'd still be teaching if the law had been in when I had to retire in 1970, and I'd left the classroom.
What would you guess the majority of the doctoral theses at Purdue were on in that era?
Well, this is an interesting point, and I'll answer something like this. At the time I was employed, they also employed about 5 other TAs, as I remember. And my office mate was a Harry Dixon, who came from California. And he was married to his wife, Helen, at that time. And if I remember rightly, they had 1 or 2 small children. I'm pretty sure of that fact, at that time. I know they did subsequently anyway. So he was there, and we both came at the same time. Now they had another fellow who came at the same time, and I can't remember his name, okay? And he got his degree. I make this contrast. So at least 4 of us, and I think there was a 5th, started at the same time. And, well, I remember Frank Nottingham. You remember Nottingham? He was working there as a graduate.
Nottingham ended up actually at Georgia Tech eventually.
He was working for his degree, and he got it. And he went down to Georgia Tech then. So, but there was another fellow who came at the same time as Dixon and I did. Well, maybe congenial and convivial nightlife there appealed too much to him, and somehow or other he left after a semester or 2, okay? So anyway, I finished up first of the group. It took me 4 years to get a PhD. Yeah, that was my thing. But, well, I taught this laboratory thing primarily for the first 3 years. And then in the 4th year, they gave me a little more experience. I taught an introductory course in fields using Atwater's book. And I taught measurements using Marshall's notes as they were at that time. And I had a little more experience in my 4th year. Then they also would only let you take at the beginning 1 graduate class a semester. That's supposed to be your load. And later I convinced them I could handle 2 at one time, so they allowed me to take 2. Also, you had to pass these qualifying examinations in French and German. That's an important point, because all faded out now. So I had to study and pass those subsequently.
So you were working in electromagnetics. What was Dixon working on?
I didn't work in electromagnetics. I was self-studying electromagnetic theory. There's a difference.
But your thesis really was in electromagnetics.
Well, yeah, it was that problem suggested in the footnote of Maxwell, okay? Actually, there's a 3rd edition of Maxwell that came out in 1892 or 91, one or the other. And this is the edition that's still in print, and you can buy it. And maybe Dover handles it nowadays. And that's the one that, if you buy a second-hand copy, that's the one that's usually furnished and so on, see? And that was also edited by J.J. Thompson, the famous one who got his Ph.D., yeah, that's right, edited, I guess, correct word, the Nobel Prize for his work on, you might say, discovering the electron, put it that way. Yeah. Now, what I did, I took up the study of electromagnetic theory as a self-study because, to me, to understand electrical engineering and how things really operate, you have to know electromagnetic theory. Particularly, you know, in the days when radio was really sort of blossoming into the public domain in the 30s. And how do you understand electromagnetic transmission in a radio frequency sense? And this was before the days that television came into the public domain, although in the late 30s they were doing experimental work. And some television sets have been manufactured and even sold, I guess, right in New York towards the end of the 30s. And the same thing was going on in England. John Logie Baird was the pioneer, great pioneer there in television in Britain. So the whole point was to learn electromagnetic theory. So my approach was sort of simple. I decided I'd simply start and purchase myself all of the books of any consequence that had been published in electromagnetic theory, okay? And then study these systematically. So I started not with Kelvin, with Maxwell, but with Kelvin's collected papers in electricity and magnetism, which sort of was published in the early 1880s. And then I got Kelvin's books. I had to buy most of these from antiquarian stores in Britain, which are pretty well stocked in those days. After World War II, universities expanding cleaned them out, huh?
You did this while you were at Purdue?
Yeah. So I bought these books, yeah. And so then I took up the study of Maxwell. Now, once I had finished Maxwell, the next step was to study the collected papers of Oliver Heaviside. There's 5 volumes. First 2 volumes primarily relative to telegraph, and this next 3 volumes relative to, called Electromagnetic Theory. The overall title for the next 3 volumes. Well, it's concerned with primarily with the great work that Heaviside did in the development of telegraph transmission, or telephone transmission theory, and also telegraph for that matter, yeah. He was a great expositor of Maxwellian theory to the electrical engineering profession, although I must say that most of the electrical engineering profession didn't understand his expositions. They were published in the Journal Electrician and otherwise, you know. Still, anyway, he was a great pioneer in Britain of introducing Maxwellian theory into the engineering profession, electrical engineering profession, you know.
When did Maxwell's stuff get put into vector notation? Maxwell never wrote it down that way, I don't think, did he?
Well, let me put it a different way. He didn't use the word vector analysis because that was sort of coined in the 1880s, okay? But you have to remember that there were earlier mathematicians that did a sort of a vector analysis kind of operation. For example, the German mathematician Grassmann, Grassmann, had worked out a kind of a vector analysis which never really took. And there were a couple other mathematicians that had worked out similar, like Hamilton, who worked out quaternions. They are a great Irish mathematician, you see. So that in Maxwell's book, he didn't use vector symbolism because it hadn't yet been developed in the sense of the heavy notation for vectors, boldfaces they call it, and so on. Mm-hmm. But you will find that he uses terms, something like, I don't want to quote any particular term, but he uses terms that are sort of the equivalent, if not the exact, of things like divergence and curl and so on. Those specific ones might have been introduced a little bit later, but the equivalent, so he uses there. And he uses quaternions a little bit. If you carefully read those 2 volumes, you find he uses quaternions. However, when Heaviside started working in electromagnetic theory, he thought quaternions were too awkward for electromagnetic theory as he was developing it, you see. And at the same time in the United States, J. Willard Gibbs at Yale who was also developing electromagnetic theory, had come to the same conclusion, and he was developing his vector analysis. Well, when their work started to be published and each read the others, they recognized that they were doing similar and sort of overlapping kinds of development, and they opened up a correspondence. And you can find the collected correspondence between the two if you know where to look. It's been published, some of it at least, not all of it. And therefore, the two collaborated in the sense of the development of terminology, notations, and otherwise, to formulate finally the body of theory which is now commonly recognized as vector analysis. And as a matter of fact, subsequently, one of J. Willard Gibbs' students, by the name of Wilson, wrote a 500 and some odd page book on vector analysis, which I consider still one of the very best treatments on vector analysis. Wilson later had a long career at Harvard University and really sort of ended up in public health, and this is the end of his career. Yeah, but this Wilson's book is really an excellent. You can find it in math libraries. Yeah.
So would you guess that almost everybody was doing a thesis in those days was looking at electromagnetic type problems?
Well, no, actually, how many people did thesis? There weren't many PhD students.
Well, you said there were 5 about the time you
Well,
came in.
5 of us started at that time, okay? And I was the first to finish 4 years later.
What did Nottingham do, you recall?
Well, Frank, yeah, I can recall, but let me finish up the thought because it's already in my mind. You see, I worked that problem that I remarked, okay? And Dixon, I kept in contact with Dixon to this day. We exchanged Christmas letters and occasionally maybe one in between and so on. He's now retired as a consulting engineer. He finally ended up out in the San Francisco region. Frank was interested in a problem that's been long studied from time to time by a lot of people in here, vibrations of transmission lines. Okay, that was his, I remember his project, but he finished after I left, as I recall. See, now before I left. And one fellow was working on, in the radio field there, the fellow's name I can't remember. I was going to say Hakama, but that's not true, because Hakama was a member in the, Frank Hakama has something to do with the university administration, maybe some kind of finance officer or something. But it began with H, and I just can't remember. So he, I think, worked in the radio frequency range. See, when I went there, there was nobody that knew electromagnetic theory on the faculty, because they didn't teach it in those days, you see, except one man. And he had come from the East. And his name was Charles, and if I recall roughly, something like Adkins or Atkins, okay? And he gave a 3-credit course on electromagnetic propagation, sort of plane wave theory kind of thing, where you listened to him right on the board, and you took down notes, and okay? You know, that kind of approach. And but at the end of 1 year, he said, oh, okay, I got to go back east again. So he left the faculty and went back to New Jersey, where he set up as a consulting engineer. So he was the only man doing electromagnetic theory. Well, over in the physics department, they had the usual, somebody teaching a 3-credit course for physics people that used books still of the nature of the old Jeans book, Electricity and Magnetism, and so on, you know, or maybe Page's book, which was an American book that was quite widely used for a number of years. I forget his first name, maybe Lai Page or something like that. But if you wanted to really know electromagnetic theory, you had to self-study it. My personal opinion is lots of people that teach electromagnetic theory using the textbook don't really know much about electromagnetic theory in the fine detail, okay? So that's what I did. I built up my own library, and subsequently I've accumulated practically every book, rather than elementary textbooks, I didn't try for them, which had been published relative to electromagnetic theory. For example, there's a 2-volume book that was published in Britain. Probably nobody around here nowadays have ever heard of it. You might find it in old physics libraries. And if I remember the name, one of the 2 co-authors was Watson, so I had a set of Watson in here. But one of the things I ran across in the search was the 1910 volume by Whittaker, which was a historical account of the development of electromagnetic theory to that time when Whittaker, who was then the Royal Astronomer of Ireland, wrote that book. And subsequently, as I remember telling you yesterday, Whittaker returned to Britain, became professor of mathematics, and if I remember rightly, he was at Edinburgh and spent the rest of his career, and published actually several other books of things, but primarily a mathematician. And you must know the famous book Whittaker and Watson on sort of all the analysis ever up to date applied mathematician and physicists should know. Famous book, right? That kind of thing was later sort of superseded, I thought, by Harry Bateman, by Harold Jeffrey's book, and his wife Bertha, who wrote a book that passed was revived. The same thing, but at a later time, yeah. Primarily for physics, sort of something like mathematical methods in physics, yeah. So another professor who was there was Professor Siskin, and Siskin was an assistant professor, if I recall his title, at Harvard. But when Conant became president of Harvard in the Depression years, and I suppose they had budget problems like everybody else, he sort of cleaned house of a lot of assistant professors that didn't go on to gain tenure. So Siskin had left and received an appointment at Purdue in the electrical engineering department, and maybe he'd come a year earlier than when I came, but he hadn't been there too long. And he was the one who taught what was the equivalent of radio engineering. Remember, 37 to 41, yeah. The first two books really on radio engineering had been published only in the late 30s by Terman and by Everett, yeah. So he probably used one of those two texts in his current treatment. And another one who was there was another Siskin. Now, this other Siskin was an interesting character. I think his name was Charles, if I remember rightly. The first Siskin wasn't Charles, so I forget. Oh, Robert. First one was Robert, and this one was Charles. And Charles had his office right next to mine, and Dixon's the office we shared. And he was interested in, he was sort of a practical engineer. And he wrote a couple of rather small books on rotating machines and things like that. You probably find them in our library here. But he was a sort of a smaller man in frame, and some of the others, both Ewing and Professor Harding, for example, were probably 6-footers thereabout. So what I meant by smaller frame, and he sort of taught sort of basic courses for non-electrical engineers and things like that, as I remember. But he had some EEs too. But anyway, he seemed to be content. He was single, as I remember at that time. He divorced earlier, and he spent his career there. He retired and died. And another one who was there was Professor Lester Beck, and he was the one who had the responsibility of looking after the several instructors for these non-electrical engineers. We worked under his supervision. He's still alive, but in not very good health in recent years, and although I sent him Christmas cards for several years, I haven't gotten a reply, but I understand because he's in very poor health. But another one who was there, Professor George Mueller, and he had one of those offices that I mentioned, really adjacent to the other offices. There was a bank of it there. And Mueller wrote several books. You'll find them in the library on rotating machinery, was his specialty. And he also gave an elective course in heavy-size operational calculus, which I took when I was a student. I'd had a course earlier from Cornell, so it was sort of some overlap there with Karapetov. And subsequently, Mueller left. See, when Harding died the year after, or maybe the year when I was at Tulane, it was the year after I left Purdue, he had died suddenly, maybe a stroke. He was succeeded by D.D. Ewing, who for 10 years was the chairman then. And after Ewing retired, I think Mueller had hopes he would be the chairman. But by this time, PhD had reared its head. They wanted somebody with a PhD in development or research and all that kind of thing, you know, if you figure that. And so Mueller was not appointed the chairman. So anyway, he subsequently left and he served at other schools till he retired. He was a chairman someplace else, but I forget where. A rather smaller engineering department, electrical engineering department. And then he returned in retirement to Lafayette, where he lives to this day. And his wife, if I recall correctly, has relatives 5 or 10 miles south of Madison here. And the couple come up occasionally to visit there. And a few years ago, I entertained Professor Muir and his wife at dinner at the Inn on the Park. My last contact with him, yeah. But he's still alive, and we occasionally exchange notes.
Well, what I was trying to get at here, I guess, was I was trying to get a feel for what kind of topics and the scope of the PhD program.
Well, I've mentioned some of them. Don't you see the courses that each one of
yeah.
those professors taught?
Dixon was working in what we call the power area, I guess.
Yeah, he probably did something on rotating machines relative to power. You know,
So-
that's my guess. I don't remember his exact thesis title.
Basically, we're talking about circuits,
Circuits?
radio stuff.
Primitive stuff, because they had a Professor Royce there who taught basic electronics was one of his areas. But actually, they'd only formalized, this was a very curious thing in a way, if you start to think about it time-wise, they'd only formalized the teaching of electronics in a laboratory while I was a graduate student there. And he had hoped to become the director of that lab, but there was another one there, a very handsome, good-looking fellow, something like you, about the same height, curly hair, and so on. That was appointed the director, so he didn't. And this man spent the rest of his career until he died some years later. And I guess there was one more professor, and I was trying all this time to recall his name because his father, not his father, but his son, subsequently stayed on at Purdue, after finishing his university education wherever, and returned to Purdue. And he's in recent years been sort of the editor of books published by Purdue University Press.
Okay, we're at the end of this tape.
Okay.
That's pretty good.